Welcome students, we've been expected to solve this question. This is a 2020 Integration Bee Berkeley question. Now to solve this question we would be using this result. This is called as the Gaussian Integral. So the result is integral negative infinity to infinity e raised to the power of negative x squared dx is equal to root of pi. So we would be making use of this particular result. Of course, I have also made a proof for this. You can visit that proof also if you would like to know how exactly you can get when you are integrating e raised to the power of negative x squared between negative infinity to infinity, the value being root of pi. So in this particular question I would be just making use of this particular result. So foremost, what I wish to do is I would like to rewrite. I have been given integral negative infinity to infinity e raised to the power of negative x squared times e raised to the power of negative 1 over x squared. Now we know the result. A raised to the power of m times a raised to the power of n is equal to a raised to the power of m positive n. So we have e raised to the power of negative x squared times e raised to the power of negative 1 over x squared. This is equal to e raised to the power of negative x squared negative 1 over x squared, which can be rewritten by taking negative sign out as x squared positive 1 over x squared. Now this is actually x positive 1 over x the whole squared. How do I say that? If I were to expand this, I would get x squared positive 1 over x squared followed by positive 2. The only thing that is missing here is the 2, and that could be taken away. Now having mentioned that, I also can produce this quantity because that is the objective, right? By taking x negative 1 over x raised to the power of 2, because if I were to expand it I would get x squared positive 1 over x squared. In this case it's going to be negative 2. So there are two ways by which I can actually produce x squared positive 1 over x squared. Now let me just take this particular case. So I'm going to show you that what happens. So case 1 is making use of x positive 1 over x raised to the power of 2. So what I wish to do is I'm going to substitute this over here. So this is going to be equal to integral negative infinity to infinity e raised to the power of negative, open the parenthesis, this is going to be x positive 1 over x raised to the power of 2 followed by, actually I need to get rid of this 2 because from here I would get a positive 2. So this is actually going to be a negative 2, right? Because when we expand this I would get x squared positive 1 over x squared positive 2. I need to remove that positive 2. The only way I can remove the positive 2 is by having a negative 2 here. So this is times dx. Now I can rewrite this as this is equal to integral minus infinity to infinity e raised to the power of, I am pushing the negative sign inside, so it's going to be negative of x positive 1 over x raised to the power of 2. I'm pushing the negative sign, so that's going to be positive 2 times dx. I can rewrite this as integral negative infinity to infinity e raised to the power of negative x positive 1 over x raised to the power of 2 times e raised to the power of 2 times dx. How am I able to write this? Because of the formula a raised to the power of m positive n, or any quantity for that matter. It can be positive n or negative n. I can write it as a product. So that's the reason I'm writing it in this fashion. So moving on. So now this can be rewritten as this is equal to e raised to the power of 2 integral negative infinity to infinity e raised to the power of negative of x positive 1 over x raised to the power of 2 times dx. Now there is a formula that we studied in property of integration. If I have something like this, negative a to a f of x times dx, this is equal to 2 times integral 0 to a f of x dx, provided f of x is even. Right? Now clearly if you were to see in this case, this is the observation, this is the constant. This is actually an even quantity, an even function, because it's a square, x positive 1 over x. So what I'm going to do is I'm going to rewrite this as e raised to the power of 2 times 2 times integral 0 to infinity e raised to the power of negative of x positive 1 over x raised to the power of 2 times dx. Now I need to make the substitution. I do not have much space here, so I would like to move to the next page and perform the completion for this question. So now I wish to make the following substitution. I would like to take, let u be equal to 1 over x. So from here I can rewrite x to be equal to 1 over u. And having written this, if I were to take the dx part for this, if I were to differentiate, this is going to be dx is equal to, I can rewrite this as u raised to the power of negative 1. And if I were to differentiate, this is going to be negative 1 u raised to the power of negative 2 times du, which is equal to negative 1 over u squared times du, which is my dx. So let me substitute that over here. So this is going to be 2 times e squared. I'm not going to alter the limits. Let us keep the limits, and then finally we will change the limits. So this is going to be e raised to the power of negative. So in place of x, I'm going to substitute 1 over u for this x, and in place of 1 over x, I'm going to substitute u and raised to the power of 2. In place of dx, I'm going to substitute negative 1 over u squared times du. So if I were to substitute the limits now, when x is equal to 0, so we can do that here. When x is equal to 0, u is equal to infinity, and when x is equal to infinity, my u is going to be 0, right? So let us substitute that. So for 0 it's going to be infinity, for infinity it's going to be 0. So this is how the limit takes form. Now I got a negative sign. Now if I were to get rid of the negative sign, drop the negative sign, that means the limits will change. So this is equal to 2 times e squared integral 0 to infinity e raised to the power of negative of, I'm going to write this as u positive 1 over u raised to the power of 2 times 1 over u squared times du. Now there is a property in integrals, that is, this is the property. Integral 0 to a f of x dx is equal to integral 0 to a f of u times du. In other words, by changing the variable from x to u, the integral remains the same, right? So there wouldn't be any change at all. So in other words, what I'm trying to tell you here is, if I were to rewrite u back to x, the integral quantity will still remain unaltered. So this is equal to 2 times e integral 0 to infinity e raised to the power of negative of x positive 1 over x raised to the power of 2 times 1 over x squared times dx. So this is what I've got. So the idea now is, we started from here. If I were to take this as I, and we actually transformed the original integral which we have over here to an integral of this fashion. So this is actually the transformation that we have just received. Now what I'm going to do is, I'm going to take this as say 2, and I'm going to take this as 3, and then adding 2 with 3, I would get 2 times I is equal to, I would like to place this first, 2 times e raised to the power of 2 integral 0 to infinity e raised to the power of negative of x positive 1 over x raised to the power of 2 times dx positive 2 times e raised to the power of integral 0 to infinity e raised to the power of negative of x positive 1 over x raised to the power of 2 times 1 over x squared times dx. Now if I were to take the quantity as common, this quantity as common along with the integral, I would get the following. So it's going to be 2 times, so there is one particular change we have to do because this is a constant, right? So I should have this as e raised to the power of 2 because this constant is not affected at all. So this is going to be e raised to the power of 2. So we got now 2 times e raised to the power of 2. And if I were to take this integral out, I would get integral 0 to infinity e raised to the power of negative of x positive 1 over x raised to the power of 2. If I were to take that out, I would have a 1 over here positive 1 over x squared here times dx, because this into 1 into dx would give me this term, this into 1 over x squared into dx would give me the second term. Fair enough. Now let us substitute for x positive 1 over x. Now let x positive 1 over x be equal to some v. If I were to differentiate this, I get 1. If I were to differentiate this, I get negative 1 over x squared times dx is equal to dv. Now clearly you can see here, this is positive, this is negative. If only we would have added a negative sign here, this entire question is completed, it's finished. But apparently we do not have that negative sign here. So what is the understanding here? The understanding here is we have to take a detour. So instead of, actually if you would have remembered, I started with this quantity e raised to the power of negative of x squared positive 1 over x squared. I said this quantity x squared positive 1 over x squared can be generated in two ways. If I were to take x positive 1 over x raised to the power of 2, and if I were to expand this, I would get x squared positive 1 over x squared, that's the first term. Of course there's the addition of a positive 2 which could be removed. So I took this route and I found myself with the negative sign missing. Now there is another way which is nothing but x squared positive 1 over x squared being rewritten as x negative 1 over x raised to the power of 2. So in this case I would get a negative 2, and all I need to do is to place a positive 2. So I went along this direction and I hit the wall, right? So now I need to drop this substitution and I have to use this substitution. So let me just do that. So all I need to do is I need to start from here. All I need to do is I need to start from here. This is the point I need to start, but with a difference. So let me show you the difference. So let me write that down. The original problem, I being equal to integral negative infinity to infinity. So that would have to be acting on e raised to the power of negative of x positive. In fact, it should be this quantity x squared positive 1 over x squared times dx. This is what we add, right? So I'm rewriting this as integral negative infinity to infinity e raised to the power of negative of, I'm going to use this term. So this is going to be x negative 1 over x raised to the power of 2. So it's going to be positive 2, because if I were to expand this, I would get x squared positive 1 over x squared. That's fair enough. But I would get a negative 2 coming out. So that negative 2 has to be neutralized with a positive 2. So this is what we should now add. So if I were to rewrite this, I would have here negative infinity to infinity e raised to the power of negative of x negative 1 over x. Let me write this like this, raised to the power of 2 times e raised to the power of negative 2 times dx, right? So if I were to move this is going to be e raised to the power of negative 2 integral negative infinity to infinity e raised to the power of negative of x negative 1 over x raised to the power of 2 times dx. Now this has got a 2 there, so it's an even function. So I'm going to rewrite this as 2 times e raised to the power of negative 2 integral 0 to infinity e raised to the power of negative of x negative 1 over x raised to the power of 2 times dx. So that's fair enough. So let me take u to be equal to 1 over x, and then from here my x would be equal to 1 over u, so dx is going to be equal to negative 1 over u squared times du. So if I were to substitute that, this is going to be equal to 2 times e raised to the power of negative 2 integral e raised to the power of, in place of x it's going to be 1 over u, and in place of 1 over x it's going to be u, this is raised to the power of 2, and then in place of dx it's going to be negative 1 over u squared times du. And the limits, when x is equal to 0 you get u to be infinity, when x is equal to infinity u to be equal to 0. Now I already told you that this negative sign can be exchanged for the change of limits. So if I were to do that, this is equal to 2 times e raised to the power of negative 2, limits are 0 to infinity, e raised to the power of negative of. Now what I can do is I will have to make some changes with reference to the u that we have. Now I got a 2 here as an exponent, so if I were to take a negative sign out and place the quantity inside to be as negative 1 over u, right, something like this fashion, because negative times negative 1 over u would give you a positive 1 over u, followed by, I need to have a negative there, so this is going to be a positive u, right, and the exponent is 2 multiplied with 1 over u squared times du. Now you will understand why am I writing it like this. So this is equal to 2 times e raised to the power of negative 2 integral 0 to infinity e raised to the power of. Now if I were to apply the square for this negative sign, I would get a positive quantity, and subsequently I would be able to rewrite this as u negative 1 over u raised to the power of 2, right, times 1 over u squared times du. Now applying the property in integrals, I can replace u with x. So this is now equal to 2 times e raised to the power of negative 2 integral 0 to infinity e raised to the power of negative of x negative 1 over x raised to the power of 2 times 1 over x squared times dx. So this is our new I. So let me write that down after the transformation. Now for the all important final step. So we had this I is equal to 2 times e raised to the power of negative 2 integral 0 to infinity e raised to the power of negative of x negative 1 over x raised to the power of 2 times dx. And from here we landed up with 2 times e raised to the power of negative 2 integral 0 to infinity e raised to the power of negative of x negative 1 over x raised to the power of 2 times 1 over x squared times dx. So if I were to take this as 4, if I were to take this as 5, adding 4 with 5, we get, so what do we get? This is going to be 2 times I is equal to 2 times e raised to the power of negative 2 integral 0 to infinity e raised to the power of x negative 1 over x the whole square times dx positive 2 times e raised to the power of negative 2 0 to infinity e raised to the power of x negative 1 over x raised to the power of 2 times 1 over x squared times dx. If I were to take 2 common e raised to the power of negative 2 common, and the integral quantity 0 to infinity e raised to the power of negative of x negative 1 over x the whole square common, this is going to be 1 positive 1 over x squared times dx. Now if I were to take, let x negative 1 over x be equal to some v, if I were to differentiate, I get 1 positive 1 over x squared times the dx is equal to dv. So this is handled here. So this is going to be equal to 2 times e raised to the power of negative 2 integral. This is e raised to the power of negative v squared. This is going to be my dv, and when x is equal to 0, we would get a negative infinity. When x is equal to infinity, we would get a positive infinity. Now this is similar to 2 times e raised to the power of negative 2, negative infinity to infinity, e raised to the power of negative x squared times dx. And that is nothing but the Gaussian integral. So we add the Gaussian integral to be equal to root of pi. So this is going to be 2 times e raised to the power of negative 2 times root of pi. This is a beautiful question. Of course, I have done this in very elaborate fashion, mainly because to render understanding. And apparently it is imperative to mention here the time given to solve this question is 4 minutes. And if you are well aware of the flow, I would suggest this question can be solved less than 4 minutes. So thank you students, I hope you enjoyed this class. We will meet again.